Imagine walking across mudflats at low tide and discovering that beneath your feet lies one of the ocean's most productive natural farms. Every year, commercial cockle operations harvest over 200 million pounds of these small but mighty shellfish from coastal waters around the world. These heart-shaped bivalves represent a $400 million global industry that's feeding millions while simultaneously cleaning our oceans. What makes cockles so special that they've sustained entire coastal communities for centuries? How do modern farmers cultivate millions of these filter-feeding shellfish in sustainable operations that actually improve marine environments? And what industrial processes transform freshly harvested cockles into the seafood products found in markets from London to Los Angeles? Welcome to AgriCraft, where we dive deep into the world's most fascinating agricultural and aquacultural processes. Today we're exploring the remarkable journey of cockle farming, a form of sustainable aquaculture that combines traditional knowledge with cutting-edge agriculture technology. From the careful seeding of mudflats to the high-speed processing plants where millions of cockles are cleaned and packaged daily, all will be revealed in this video. The story of cockle cultivation stretches back over 2,000 years to ancient Roman settlements along European coastlines. These ingenious coastal dwellers discovered that cockles naturally thrived in the intertidal zones where fresh river water mixed with salt water, creating nutrient-rich environments perfect for filter-feeding bivalves. Unlike many marine species that required dangerous deep-water fishing, cockles could be harvested safely during low tides by walking across exposed mudflats. Traditional cockle gathering involved entire families working together during the brief windows when tides exposed the beds. Harvesters used simple tools like rakes and sieves to collect cockles by hand, learning through generations of experience exactly where and when to find the highest quality specimens. This knowledge of tidal patterns, seasonal cycles, and cockle behavior became the foundation for modern commercial operations. The transformation from small-scale gathering to industrial cockle farming began in the mid-20th century, when marine biologists discovered they could dramatically increase natural cockle populations through careful management and health seeding programs. Rather than simply harvesting wild populations, farmers began actively cultivating cockle beds by introducing juvenile cockles to optimal growing areas and managing environmental conditions to maximize survival and growth rates. Today, the global cockle industry spans multiple continents with major production centers in the United Kingdom, Netherlands, Spain, South Korea, and increasingly along the Pacific coast of North America. The United Kingdom alone produces over 40,000 tons of cockles annually, making it one of Europe's largest shellfish industries. These operations support over 15,000 jobs directly while contributing hundreds of millions of dollars to coastal economies. Modern cockle farming represents a perfect example of sustainable aquaculture. Unlike traditional fishing that depletes wild populations, cockle cultivation actually enhances marine ecosystems. Each adult cockle filters up to 8 gallons of seawater daily, removing excess nutrients and algae while improving water clarity and quality. This natural filtration process helps combat coastal pollution and creates healthier marine environments for other species. The environmental benefits extend beyond water filtration. Cockle beds provide crucial habitat for numerous marine species including shorebirds, crabs, and juvenile fish. The complex ecosystem that develops around established cockle farms supports biodiversity levels that often exceed those found in unmanaged coastal areas. This makes cockle farming one of the few agricultural practices that actively improves environmental conditions while producing food. Successful cockle farming begins with selecting optimal locations that provide the perfect balance of environmental conditions these filter feeders require. The ideal cockle habitat combines specific water salinity levels, appropriate water depth, suitable substrate composition, and adequate food supply in the form of phytoplankton and organic particles. Site selection involves extensive environmental testing to measure water quality parameters including salinity, temperature ranges, dissolved oxygen levels, and nutrient concentrations. Cockles thrive in estuarine environments where salinity levels remain between 20 and 35 parts per thousand, allowing them to maintain proper osmotic balance while maximizing feeding efficiency. The substrate or seafloor composition plays a crucial role in cockle cultivation success. These bivalves prefer sandy or muddy bottoms that allow easy burrowing while providing stability during strong currents and storms. Professional site surveyors use specialized equipment to analyze sediment composition, ensuring the substrate contains appropriate percentages of sand, silt, and organic matter. Water depth management is critical for cockle farming operations. Most commercial farms operate in intertidal zones or shallow subtidal areas where water depths range from just above low tide level to approximately 6 feet at high tide. This depth range allows for efficient harvesting using specialized equipment, while ensuring cockles receive adequate water flow for feeding and respiration. The seeding process begins with obtaining juvenile cockles either from natural spawning areas or specialized hatchery operations. Hatchery-produced cockles offer advantages in terms of disease control and genetic selection, while wild-caught juveniles often demonstrate better survival rates in natural environments. Many commercial operations use a combination of both sources to optimize their seeding programs. Juvenile cockles measuring between 5 and 15 millimeters are carefully distributed across prepared beds using specialized seeding equipment. The density of placement is critical, as overcrowding can lead to competition for food and reduced growth rates, while too sparse distribution fails to maximize the productive potential of available habitat. Optimal seeding densities typically range from 200 to 500 cockles per square meter depending on environmental conditions. Environmental monitoring becomes essential during the early growth phases. Farmers regularly test water quality parameters and monitor cockle mortality rates to identify potential problems before they impact entire beds. Modern cockle farms employ automated monitoring systems that continuously track temperature, salinity, dissolved oxygen, and other critical water quality indicators. Predator management represents one of the biggest challenges in cockle cultivation. Shorebirds, crabs, starfish, and various fish species consider juvenile cockles a preferred food source. Commercial operations employ multiple strategies to protect their stocks, including predator exclusion nets, regular bed maintenance, and strategic timing of seeding operations to minimize predation risks. The growth period for commercial cockles typically ranges from 18 months to 3 years depending on environmental conditions and target size requirements. During this time, cockles filter feed continuously, converting phytoplankton and organic particles into high-quality protein while gradually increasing in size and developing the thick shells that protect them from predators and environmental stresses. Regular monitoring throughout the growing period involves sampling cockle populations to track growth rates, assess health status, and determine optimal harvest timing. Professional cockle farmers use standardized sampling techniques to estimate population density and average size, allowing them to predict harvest yields and plan processing operations accordingly. Harvesting cockles requires precise timing to ensure optimal quality and maximum economic return. Commercial cockle harvesting typically occurs during spring and summer months when cockles reach peak condition following winter dormancy periods. The timing must also coordinate with tidal cycles, as most harvesting operations require access to beds during low tide periods. Modern cockle harvesting employs specialized equipment designed to efficiently extract cockles while minimizing damage to both the shellfish and the marine environment. The most common harvesting method uses suction dredging equipment that gently lifts cockles from the substrate using controlled water pressure rather than mechanical scraping that can damage shells and disturb sediment layers. Suction dredging systems consist of powerful pumps that create water flow sufficient to lift cockles from their burrows without excessive force. The cockles and substrate mixture is pumped aboard harvesting vessels where initial screening separates cockles from sand, shells, and debris. This gentle harvesting method maintains cockle quality while allowing smaller specimens to be returned to the beds for continued growth. Alternative harvesting methods include mechanical raking systems for shallow water operations and hand harvesting techniques still used in some traditional operations. Hand harvesting, while labor-intensive, produces the highest quality cockles with minimal shell damage, making it preferred for premium market segments despite higher labor costs. Quality assessment begins immediately during harvesting operations. Experienced harvesters evaluate cockle size, shell condition, and meat quality to determine grading categories. Premium-grade cockles feature intact shells, plump meat content, and uniform sizing that meets specific market requirements for restaurant and retail customers. Transportation from harvest sites to processing plants requires careful handling to maintain cockle viability and quality. Live cockles are transported in specialized containers with controlled temperature and moisture conditions that keep shellfish alive during transport. Processing typically occurs within 24 hours of harvest to ensure optimal freshness and food safety standards. The volume of cockles harvested during peak seasons can be substantial. A single commercial harvesting operation might collect between 5 and 15 tons of cockles per day during optimal conditions. This requires coordination between harvesting crews, transportation logistics, and processing plant capacity to handle the continuous flow of fresh shellfish. Harvesting operations also involve environmental stewardship practices, including rotation of harvest areas to allow beds to recover, leaving percentage of adult cockles for breeding stock, and monitoring the impact of harvesting activities on surrounding marine ecosystems. These sustainable practices ensure long-term viability of cockle farming operations. The transformation of freshly harvested cockles into market-ready seafood products occurs in specialized processing plants that combine traditional shellfish handling techniques with modern food processing technology. These facilities must maintain the highest standards of food safety and hygiene, while efficiently processing large volumes of live shellfish. Processing begins with initial sorting and quality inspection, where trained workers evaluate each batch of incoming cockles. Automated sorting systems separate cockles by size using vibrating screens and conveyor belt systems that route different grades to appropriate processing lines. This initial grading ensures consistent product quality and allows facilities to meet specific customer requirements. The cleaning process represents the most critical stage of cockle processing. Industrial machines designed specifically for bivalve cleaning use high-pressure water jets and rotating brushes to remove sand, algae, and debris from cockle shells. This automated cleaning system processes thousands of cockles per hour while maintaining gentle handling that preserves shell integrity. Following mechanical cleaning, cockles undergo multiple washing cycles in temperature-controlled water systems that remove any remaining contaminants. The washing process uses filtered seawater or specially prepared saltwater solutions that maintain cockle viability while ensuring thorough cleaning. Quality control technicians monitor the cleaning process to verify that hygiene standards meet international food safety requirements. Modern cockle processing plants employ sophisticated sterilization procedures to eliminate harmful bacteria and ensure product safety. Steam treatment systems expose cockles to precisely controlled temperatures and steam pressure that eliminate pathogens without overcooking the delicate meat inside the shells. Temperature control during sterilization is critical, as excessive heat can toughen cockle meat and reduce product quality. For products requiring shucked cockle meat, specialized shucking machines use steam heat to partially open shells, allowing mechanical extraction of meat from shells. These industrial machines process thousands of cockles per hour, separating meat from shells with minimal waste. The extracted meat undergoes additional washing and inspection before packaging. Advanced processing facilities incorporate automated grading systems that use optical scanning technology to evaluate cockle size, shell condition, and meat content. These systems ensure consistent product grading and help maintain quality standards across large production volumes. Rejected cockles are either reprocessed or diverted to alternative product streams. Quality inspection procedures throughout processing include regular testing for bacterial contamination, heavy metals, and other potential contaminants. Laboratory facilities within processing plants conduct microbiological testing to verify that products meet strict food safety standards required for domestic and international markets. The processing plant environment maintains controlled temperature and humidity conditions that preserve cockle quality while meeting hygiene standards. Stainless steel equipment and sanitization systems ensure that processing areas can be thoroughly cleaned between production runs, preventing cross-contamination and maintaining food safety protocols. Processing operations also generate valuable byproducts, including cockle shells that are processed into calcium supplements, agricultural lime, and decorative materials. The shell processing operation adds additional revenue streams while minimizing waste from cockle processing operations. Packaging systems for processed cockles employ automated equipment designed to handle the specific requirements of live and processed shellfish products. Live cockles are packaged in specially designed containers that allow air circulation while preventing moisture loss during storage and transportation. These containers often incorporate absorbent materials that manage moisture levels and extend product shelf life. For fresh cockle meat products, vacuum packaging systems remove air from packages to prevent oxidation and extend refrigerated storage life. Automated packaging lines can process thousands of packages per hour, applying consistent sealing and labeling to meet retail and food service requirements. Each package includes detailed labeling with harvest date, processing information, and storage instructions. Cold storage facilities maintain precise temperature control throughout the packaging and distribution process. Refrigerated storage areas keep cockles at temperatures between 32 and 38 degrees Fahrenheit, while frozen product storage maintains temperatures below 0 degrees Fahrenheit. Temperature monitoring systems continuously track storage conditions to ensure product safety and quality. Advanced packaging operations include modified atmosphere packaging that replaces air in packages with specific gas mixtures that extend shelf life and maintain product quality. These systems use nitrogen and carbon dioxide blends that slow bacterial growth and prevent oxidation while preserving the natural color and texture of cockle meat. Labeling systems apply comprehensive product information including species identification, harvest location, processing date, nutritional information, and cooking instructions. Export products require additional labeling in multiple languages and compliance with international food safety regulations. Automated labeling machines ensure consistent label placement and legibility across high-volume production runs. Distribution logistics for cockle products involve complex cold chain management systems that maintain product quality from processing plant to final consumer. Refrigerated transportation vehicles maintain precise temperature control during shipping, while tracking systems monitor temperature conditions throughout the distribution process. The global distribution network for cockles includes specialty seafood distributors, retail grocery chains, restaurant suppliers, and export markets. Major export destinations include European Union countries, Asian markets with strong seafood consumption traditions, and growing markets in North America where consumer interest in sustainable seafood continues expanding. Domestic distribution channels serve both retail and food service markets with different packaging and portion sizes optimized for each market segment. Retail packages typically range from 1 to 2 pounds for consumer convenience, while food service packaging may include bulk containers of 10 to 20 pounds for restaurant use. International shipping requirements include complex documentation for customs clearance, health certificates from government inspection agencies, and compliance with importing country regulations. Many cockle processing facilities maintain certifications for multiple international markets, allowing them to serve diverse global customers. Storage and inventory management systems track product age and ensure proper rotation of perishable inventory. Computerized systems monitor storage conditions and alert managers to any temperature deviations or other conditions that might compromise product quality during the distribution process. The cockle farming and processing industry generates several valuable byproducts that contribute to overall operation profitability and environmental sustainability. Cockle shells, which represent approximately 60% of total cockle weight, are processed into various useful products rather than being discarded as waste. Processed cockle shells serve as excellent sources of agricultural lime for soil amendment. The high calcium content makes ground cockle shells valuable for adjusting soil pH in acidic agricultural areas. Many cockle processing facilities operate shell grinding operations that produce agricultural lime products sold to local farmers and commercial agricultural operations. The aquaculture industry uses processed cockle shells as calcium supplements in fish and shrimp farming operations. The shells provide essential minerals for healthy shell and bone development in cultured species, creating a secondary market that adds value to cockle processing waste streams. Construction and landscaping industries utilize cockle shells for decorative applications including pathway materials, garden mulch, and architectural features. The attractive appearance and natural durability of cockle shells make them popular alternatives to traditional gravel and stone products in coastal areas. From a culinary perspective, cockles are prized for their sweet, briny flavor and tender texture when properly prepared. Traditional preparation methods include steaming, boiling, and incorporating into seafood stews and chowders. Modern culinary applications include cockle pasta dishes, seafood risottos, and Asian-style stir-fry preparations. Nutritional analysis reveals that cockles are exceptionally rich in protein, containing approximately 15 grams of protein per 3-ounce serving. They also provide significant amounts of iron, vitamin B12, and other essential nutrients while remaining low in calories and fat. This nutritional profile makes cockles attractive to health-conscious consumers seeking sustainable protein sources. The environmental impact of cockle farming represents one of the industry's strongest selling points for environmentally conscious consumers and regulatory agencies. Unlike many forms of animal agriculture that consume resources and produce waste, cockle farming actually improves environmental conditions in coastal areas. Each adult cockle filters several gallons of seawater daily, removing excess nutrients that might otherwise contribute to algae blooms and water quality problems. This natural filtration process helps maintain healthy marine ecosystems while producing high-quality protein for human consumption. Carbon sequestration represents another environmental benefit of cockle farming. As cockles build their calcium carbonate shells, they remove carbon dioxide from seawater and convert it into stable shell material. This process contributes to ocean carbon cycling and may help mitigate effects of ocean acidification in farming areas. Biodiversity enhancement occurs naturally around established cockle beds as the complex habitat structure provides shelter and feeding opportunities for numerous marine species. Research studies have documented higher species diversity and abundance in areas with active cockle cultivation compared to unmanaged coastal areas. Sustainable farming practices in cockle operations include rotation of harvest areas, maintenance of breeding stock, monitoring of environmental conditions, and coordination with marine conservation agencies. These practices ensure that cockle farming operations remain environmentally beneficial while maintaining long-term productivity. The cockle industry has also developed comprehensive traceability systems that track products from farm to consumer, allowing for rapid response to any food safety concerns and providing transparency for environmentally conscious consumers who want to verify the sustainability of their seafood choices. From the carefully managed coastal beds where millions of cockles filter and clean our ocean waters to the sophisticated processing plants where they're transformed into premium seafood products, we've witnessed one of aquaculture's most successful sustainability stories. This industry demonstrates how traditional knowledge combined with modern agriculture technology can create farming systems that actually improve environmental conditions while feeding growing populations. The journey from juvenile cockles distributed across mudflats to packaged seafood products in global markets represents a remarkable example of sustainable food production. Unlike terrestrial agriculture that often requires clearing land and consuming freshwater resources, cockle farming works in harmony with natural marine processes to enhance rather than degrade coastal ecosystems. The industrial scale of modern cockle operations is truly impressive. From automated harvesting systems that gently collect millions of shellfish to processing plants that handle thousands of tons annually, this industry showcases how traditional shellfish farming can evolve to meet modern market demands while maintaining environmental responsibility. What makes cockle farming particularly remarkable is its role as both food producer and environmental steward. Every cockle harvested represents millions of gallons of filtered seawater and countless removed nutrients that might otherwise harm marine ecosystems. This dual benefit creates a compelling case for expanding sustainable aquaculture operations in coastal areas worldwide. The precision required throughout the cockle farming process from site selection to final packaging demonstrates the sophistication of modern aquaculture operations. This industry proves that with proper management, marine farming can provide sustainable protein sources while supporting healthy ocean environments and vibrant coastal communities. Thank you for joining us on this fascinating exploration of cockle farming and sustainable seafood production. If you found this deep dive into marine aquaculture as interesting as we did, please give this video a thumbs up and subscribe to AgriCraft for more comprehensive looks at innovative farming and food production systems. Leave a comment below if you'd like to see more seafood documentary content, or if you have questions about sustainable aquaculture practices we covered today. Until next time, keep exploring the incredible world of modern agriculture and aquaculture.